Now what we will do? We will try to generalize this system by including more than 2 equations. Let us see. So, this is, let us say, identification in systems with identification in system with more than two equations. So far, whatever system we discussed, in all those systems there are only 2 equations. Okay. So, now let us say that this is my equation y1 equals to alpha 1 2 y2 plus alpha 1 3 y3 plus beta 1 1 z1 plus u1. Here the first subscript indicates the equation number, okay, and second subscript is the variable. So, alpha 1 2, that means that is the first equation I am denoting by 1 1 1, always 1. Similarly, y2 equals to, let us say, alpha 2 1 y1 plus beta 2 1 z1 plus beta 2 2 z2 plus beta 2 3 z3 plus u2. Then we have y3 alpha 3 1 y2 plus beta 3 1 z1 beta 3 2 z2 plus beta 3 3 z3 plus beta 3 4 z4 plus u3. So, this is a system with more than 2 equations. We have 3 equations, sometimes we have more than 3 equations also. Now, when we have 3 or more than 3 equations in a system, it is difficult to tell immediately which equation is identified, which equation is not. Okay. So, we need to find out some general condition of identification. First of all, if you look at the first equation, how many endogenous variables are there? You have 2 endogenous variables, y2 and y3. And how many variables are excluded? We have z2, z3 and z4. Okay. z2, z3 and z4, they are excluded. So, we have 2 endogenous variables, but 3 excluded exogenous variables. So, first equation is identified. Okay. So, that means in this equation y2 and y3, they are endogenous variable. These are all endogenous variable. And what are the exogenous variable? z2, z3, z4. z1 is also exogenous, but that is included in the model. So, I am not considering that. So, excluded variable are z2, z3 and z4, they are excluded. So, when you have 2 endogenous variable, 3 variables excluded, obviously order condition is satisfied. Now, when you come to second equation, what is your endogenous variable? Only y1. y1. What is your excluded variable? z4. z1, z2, z3 is there, z4 is excluded, that is also identified. Third equation, y2 is the endogenous variable. And what is your excluded variable? See, z1, z2, z3, z4, everything is there. So, excluded variable is 0. There is no variable which is excluded from the third equation. So, order condition is not satisfied. Okay, order condition is not satisfied. So, it is you have to think in this way to tell which equation is identified, which equation is not. But here I have 3 equations, I can look at and compare and check which is identified. In a system, let us say there are 50 such equations. Sometimes you may have to work with 50 equations, and it is very difficult in a system of 50 equations to see a particular equation, what are the endogenous variable, which is excluded, which is included, so many things. So, a general rule, general rank and order condition. So, this is general rank, or I would say order and rank condition. Okay. Let us assume that k is total number of variables, endo plus exo, endogenous plus exogenous in the system. Okay. Let us say that EM is total number of variables in a particular equation under identification. So, if we are thinking of whether second equation is identified or not, M is basically total number of variables in second equation. If we are thinking whether the first equation is identified or not, then M is the total number of variable in the first equation, like that. And G is total number of structural equation. Then what is the condition? K minus M should be greater than equals to G minus 1. This is the general rank order condition. So, this is the general order condition. Now, what is the meaning of this? When I am saying, let us say we are talking about equation 2. Let us think about equation 2. In equation 2, what is for equation 2? K is the total number of variables in the system itself. So, we have y1, y2, y3, these 3 endogenous variable, z1, z2, z3, z4, 4 exogenous variable. So, k equals to 3 plus 4 equals to 7. what is m for equation 2? That means when you are considering identification for equation 2, in equation 2 how many variables are there? 1, 2, 3, 4, 5. y1, y2 endogenous, z1, z2, z3 exogenous, so total 5. So, k minus m equals to 2. And what is G here? G equals to total number of structural equation 1 to 3. So, G minus 1 equals to 2. So, that means I can say that k minus m equals to G minus 1. So, second equation is exactly identified because it is equal, right. Now, if you think about the second equation individually, as I said, there is one endogenous variable and look at one excluded variable only. So, that is why from this equation I can say that easily second equation is exactly identified, right. So, this is the general formulation, and same thing is happening when you individually look at the equation also. Basically what this equation says, when I am saying k is the total number of variable and m is the total number of variables appearing in the particular equation, that means basically k minus m indicates how many variables are actually excluded. Okay. So, how many variables are excluded, and since G is the total number of structural equation, how many structural equation you can get in a system? You will get only those many structural equation as many endogenous variable you have in the system. See, here I have 3 endogenous variable y1, y2, y3. For each endogenous variable I have one structural equation. For y1 I have one structural equation, for y2 I have one structural equation, for y3 I have one structural equation. That is why G minus 1 is basically number of endogenous variable minus 1. Okay. So, that is how it is making sense, greater than or equals to. So, that means total number G minus 1 would be then the total number of endogenous variable minus 1, and this side you have excluded endogenous variable. So, this is how the general condition, order condition is satisfied, but the rank condition is little involved. Rank condition is little involved, that we need to do it separately. So, now we will discuss about rank condition. For rank condition, what we will do? We will construct a matrix. So, construct a matrix consisting of all the coefficients, coefficients of all variables. So, if you think about the first equation, okay, if you think about the first, so what I will do, first I will write all the variables. So, what is my variable? y1, y2, y3, z1, z2, z2, z3 and z4. Now, you think about the first equation. In the first equation, I have y1, so coefficient is 1. Then second equation is minus alpha 1 2, okay, minus alpha 1 2, that is the coefficient of y2, and then coefficient of y3 is minus alpha 1 3, then minus beta 1 1, and then we have no z2, no z3, no z4. Okay, right. Then for the second equation, I have minus alpha 2 1, then 1, then I have no y3, then minus beta 2 1, minus beta 2 2, minus beta 2 3, then I don't have any z4 there. Then for the first equation, third equation, I have no y1, I have only minus alpha 3 2, then I have y3, then minus beta 3 1, minus beta 3 2, minus beta 3 3, then minus beta 3 4. Okay, so this is for the first equation, this is for the second equation, this is for the third equation. Okay, and how I am writing this equation? Simply I am doing, for example, I am for the first equation, how I am rewriting: y1 minus alpha 1 2, y2 minus alpha 1 3 y3 minus beta 1 1 z1 equals to yu1. So, all the equations are written in this format. Similarly, y2 minus alpha 2 1 y1 minus minus beta 2 1 z1 minus beta 2 2 z2 minus beta 2 3 z3 equals to u2. For the third equation, what I am writing: y3 minus alpha 3 2 y2 minus beta 3 1 z1 minus beta 3 2 z2 minus beta 3 3 z3 minus beta 3 4 z4 equals to u3. So, I have converted the equation in this format to construct this matrix. Okay, to construct this matrix. Now, what we will do for rank condition? Let us say that I am considering second equation, whether rank condition, whether the second equation is identified by rank condition is not. If you are considering second equation, then you just cross the second equation like this. Okay, and then you cross all the columns. In which you have non-zero coefficients. So, you cross out all the columns in which second equation have non-zero coefficient. So, first equation, yes, I have non-zero coefficient alpha 2 1. So, this is I will cross out. Yes, this second column I have non-zero coefficient, okay, 1. So, I will cross out. Now here I don't have anything, this is 0, so I will not cross out this. This I will cross out, okay, this I will cross out, and this I will cross out, but this I will not cross out because this is 0. Is this clear? Second equation I will cross out, then I will cross out columns in which the second equation is having non-zero coefficient. This is crossed out because non-zero coefficient, this is not crossed out because this is 0, this is crossed out, this is crossed out, this is crossed out, this is not because again 0. Now after this we have to see what are the elements left. What are the elements left? So I will have a matrix of alpha 1 3, see this is not crossed out, then I have 0 here, then I have 1 here, and I have minus beta 3 4 here. This is the matrix what I got after crossing. Let us say this is A. So minus alpha 1 3 0 1 minus beta 3. Okay. So determinants of this is alpha 1 3 into beta 3 4. Okay. So for rank condition, to be satisfied, what we need, determinants of A should be not equals to 0, which implies alpha 1 3 into beta 3 4 should be not equals to 0. Okay. So that is the general rank condition which is easy to identify. Is this clear? So that means what we are doing by crossing out these rows and columns, essentially what we are trying to get, what are the variables excluded from the model? Okay, what are the variables excluded from the model? See, I have crossed out this column, so that means some variable is here. I have crossed out this column because I am excluding, because this is already Z1 is included, Z2 is included, Z3 is included. Okay, Z3 is included, but Z4 is not included. That is why I am not crossing out this. If you look at the second equation, Z1, Z2, Z3, they are actually included. So in the mechanism, the way I am crossing out, this column is I crossed out because Y2 is appearing. This column I am not crossing out. Okay, this is again crossing out because Z1 is there. This is again crossing out, Z2 is there. This is again crossing out, Z3 is there. I am not crossing out this. So these two columns I am not crossing out just to get the variables which are not appearing in that equation. Okay, and then I am getting this matrix. Okay, then I am getting this matrix, and that matrix, determinants of that matrix would have non-zero, right? Then essentially I am getting this alpha 1 3 multiplied by beta 3 4 should be not equals to 0. That is the general rank condition. And general order condition, I have already decided K minus 1 m less than equals to G minus 1. Okay. So with this we are closing our entire discussion on simultaneous equation model. Now we know what is a simultaneous equation model, what is not a simultaneous equation model. From the beginning, again if you recall, two variables must be jointly determined, but that is only necessary condition. Sufficient condition is that the equation should have their standalone meaning. That means in a system of equation, every equation should be a structural equation. Only the structural equation will have standalone meaning. Otherwise, we saw the example of saving and housing expenditure. Even though they are jointly determined, they do not form a simultaneous equation model. Then we discussed about rank and order condition of identification. Why identification is required prior to estimation? Because without identification, you don't know which equation you are estimating. As an example, you can think about the demand and supply equation. If no other variables are included, both demand and supply is a function of price only. So, I do not know whether I am estimating a demand function or supply equation, it does not make any sense. That is why if you want to estimate a demand function, you need to construct of your own the system of equation with availability of data, of course, such that the demand function is identified. That means you should specify some variables in the supply function which should not appear in the demand function, and that variable which will appear only in the supply function will act as a observed supply shifter, and when the supply curve will shift leftward or rightward, upward or downward, I can easily identify or trace out the demand function from each and every intersection. Okay, but the rank condition says, rank condition demands something more than the order. Order condition says that the variable should be only excluded from the equation. But the rank condition says the variable should not only be excluded, but also have non-zero population coefficient. Okay, that means it should be significant in the other equation. Otherwise, we cannot say that it is identified. And then lastly, we discussed about a system of equation with three or more than three equations, the general rank and order condition with this matrix algebra. So, with this we are closing our entire discussion of this simultaneous equation model. Thank you.